In this video, we're continuing our discussion of design patterns, and more specifically how to write future-proof programs by writing programs that do not have if tests. So just to catch up on where we are so far, we have a series of files that we need to process, and each of them are processed in a different way. In other words, all of the annuities have the same format of data, but a different type of data. The format of data differs from annuity to employee, and the format of data differs from employee to life insurance, and also life insurance to annuity. So we have set up a project with a series of classes that understand annuity, employee, and life insurance. Those are all tied together with a common interface called monthly item. In the class called monthly runner, we're opening a directory to where those files live, we're getting the file name, and then we're pulling off everything in the file name up to but not including that first number 0. So we're doing a little math to get the word annuity, employee, or life insurance from the file name. We take that word, annuity, employee, or life insurance, and we pass it to our factory method called create monthly item. We can take that name and we can append our package name to it, monthly processing, and given just a string of the package name plus the class name, we're able to use reflection, which is class.forName.newInstance, to then create a new object of that class, and then we return that object. So all of that we've done in a previous video, and at this point we know that monthly item in this loop is going to reflect the correct class to process whatever file we're currently iterating over. So what we need to do now is we need to continue with the command pattern. Now the command pattern is the design pattern that says we want to decouple the invocation of an operation from the knowledge on how to perform the operation. So in other words, the class called runner, or monthly runner in our case, is going to cause the event to happen. But then the individual class, annuity or employee or life insurance, will determine what to do when it's being invoked. So first, we know that monthly runner is going to cause this work to happen. Here's how we'll do that. Monthly item. And what's the method that we can invoke here? Well, equals get class hashcode notify all toString wait. Those methods are on every Java class. The only one here that is specific to the monthly item interface is this method called execute. And the method called execute accepts a file. And guess what? In this loop, we're currently iterating over the file. So with that, easy as that, what we've done is we are causing the work to happen. We're just invoking the execute method on the monthly item variable. Now what's that going to do? Well, it depends, because we don't know what object type is stored in this monthly item variable. Remember polymorphism. Variable type tells us what methods we're allowed to call. So let's go to monthly item, and what's the variable type? Monthly item. What's the method we're allowed to call here? Execute. Okay, that's half of polymorphism. Variable type tells us what methods we're allowed to call. Object type tells us what will happen when we invoke those methods. So the object type, given our constructor, can be an annuity, an employee, or a life insurance object. Let's go into annuity and see what happens in its execute method. So I scroll towards the bottom, and we see right now this execute method is not defined. So this gives us an opportunity to define what happens in this execute method. Well, let's see. We get a file, so that's a good start. With a file, we can attach a scanner. So scanner equals new scanner. And then we pass in the file. Scanner allows us to read this information one at a time. Alt-Enter, add import, there we go. Okay, next we're going to say, let's see, I'm going to open up an annuity file, and then a scanner is going to read the first line. So we're going to have Phil, and then we're going to have Smith, and then 1200, and each of this is separated by a space, which makes it easy for us to parse. So, whoops, sorry, let me run back to my annuity. There we go, there's our annuity. So I'm going to say scanner.next, and that just says read everything until you see a space. And we are going to save that. We'll save that to, let's see, first name equals scanner.next. First name, if you remember, that's one of the attributes we defined up here. First name, last name, and payment amount. So first name, just like so, and then we'll say scanner.next. which will give us the next item from this file, and we'll save that into last name. And then finally, we will say annuity payment. What was our payment amount? Equals scanner dot next int. In this case, we're going to pull that number off as an integer, so scanner dot next int. And then finally, what we can do is we can say we'll say system out print line, which we really shouldn't do from a data class like this, but just to test things out, I'll say sending annuity payment plus payment amount to, and then we'll say plus first name plus space plus last name. So you see, all of the logic here is specific to an annuity. We can do similar logic for employee and also for life insurance. So let's run into those files and let's do something similar. Copy, and back here to projects and employee. So employee, again, the execute method is undefined. So we paste in a few things, and we're going to need to make some alterations naturally. So you see, first name, last name, we're gathering that. What else do we have in an employee file? So first name, last name, then payment amount, bank, routing and transit, account. So payment amount, bank, routing and transit, and account. So back to employee. Okay, so payment amount, what do we call it here? I think here we call it payroll amount. Payroll amount. Okay, bank equals scanner dot next. And did I call it bank or bank name? It looks like. Okay, bank name. Okay, and then we'll say routing transit equals scanner dot next. And then account number equals scanner dot next, just like so. And now we'll say processing payment or processing payroll amount, and then payroll amount for employee, and then first name, last name. We'll leave it at that. We trust the bank name, routing, and actually, no, that's okay. Let's add a few more. And then we'll say plus bank, we'll do a space, plus bank name, plus space, plus routing transit, plus space, plus account number, just like so, and terminate with the semicolon. Okay, one more to go. Let's add this to life insurance. And life insurance, what do we have in a life insurance file? This is the first name, last name, bill amount, and then policy type. Okay, so first name, last name, bill amount, and policy type. So we'll start with our kind of boilerplate stuff, add in the import that we need. Okay, first name, last name is fine, and then we'll say bill amount, and then we'll say policy type equals scanner.next. So we saw scanner in a previous video. That just lets us read a file one line at a time. Did I do? Oh, I didn't do policy type. Okay, we'll add policy type here. Private string policy type. And then Alt-Enter. Whoops. Private string policy type. And then Alt-Enter. Or right-click and refactor. And encapsulate. And get and set policy type, refactor, and we're good. Okay, so now we say, we'll say, okay, sending bill, sending life insurance bill for policy type in amount of, and then we'll say bill amount to first name, last name. Okay, looks like I'm missing something there. To first name, last name. Okay, so at this point, I know that was a bit of typing, but at this point, if we take a look at our class diagram, we know annuity, life insurance, and employee, all three now implement this execute method, and each of them knows its own specific file format. So life insurance knows how to read in the data for a life insurance file. Employee knows how to read in the data for an employee file, and annuity knows how to read in the data for an annuity file. So with that being said, let's go ahead and run our project. I'm going to start by running it just essentially as without the debugger to ensure that we're getting the output that we expect to get. After that, I'll run it in the debugger. So right-click in Debug File, and first we're just going to take a look at output. We should have 3 annuities, 2 employees, and a life insurance. So let's right-click and run and see what we get. Okay, take a look. 3 annuities, 2 employees, and 1 life insurance. So you see that in our output, we got unique output based on the type of file that we're processing. Let's slow it down a little bit now and let's run it in the debugger. So I'm going to choose debug, and let's see, we're getting our same list of files. Remember, there could be 0 to 100 annuity files, 0 to 100 employees, 0 to 100 life insurance. We have to be flexible and know that these could come in at different times in different orders. So we take a look, we iterate over our file. The first type we're getting is what? It's going to be an annuity, as the first 3 will be. And now we jump down into our factory method, create an annuity object, and that's really important because you notice, again, polymorphism, the variable type here is monthly item, which is the interface. The object type is annuity, so variable type tells us we're allowed to call the execute method. But object type tells us what will happen when we call that execute method. So watch closely. While the variable type is monthly item, notice the tab that's currently highlighted as monthly runner. And what happens when I choose F7 and step in here? Take a look. I went to the annuity class. In other words, the object type is where I went. And now that object type is going to read this file, and it's going to print some information. You see that as soon as I stepped over line 70, it printed the information, send payment $1,200 to Phil Smith. F8, we know we're going to do 3 annuities, so I'll go through those relatively quickly because they'll look very similar. So 3 annuities to begin with, and there's our annuity logic, and there's our third annuity. So Phil Smith, Kaz Dolowitz, Oscar Goodman. If we take a look at the files, Phil Smith, Kaz Dolowitz, Oscar Goodman, we're simply reading in the file and we're outputting what we need to output. Okay, let's continue and let's F8. And we know the next couple that we're going to process are going to be employees. They don't have to be, but in our case, we have 2 employees. So we step in. Our factory method creates an employee object. Let's just mouse over and confirm. You see the variable type is monthly item, but the object type is employee. When I choose F7 here to step into the execute method, where are we going to go? We go to the employee class, which knows how to parse all of this information from an employee file and then print the output for that employee file. And then we're back. Okay, the next one again is also an employee. Once again, I'll mouse over so you can see the variable type is monthly item, but the object type is employee. So no surprise when I choose F7, we go in and we do the employee logic. And there we go. And F8 and F8. The last one we want to execute is going to be a life insurance object. So sure enough, I mouse over monthly item. You see the variable type is monthly item, but the object type is life insurance. So when I choose F7 to step into this execute method, watch the tab across the top of the screen. And we are now in the life insurance object. And we're now parsing according to life insurance, printing out a line about life insurance, and then returning, and at that point we have read all of the files, and so we are now complete with our program. So, in this video, we've seen how to implement the factory method and the command pattern, and if you take a look, I can now safely delete this if test. There are no if tests left in our program. So, we now have a flexible and future-proof program. But you're probably thinking to yourself, okay, well, prove it. So to be future-proof, we need to be able to handle files that we don't yet know about. So in our next video, we're going to add a new file type called mutual fund. And we're going to take a look at our program that we have right now, and we're going to determine if I add a new file type called mutual fund, what do I need to change in this program to get it to work? So the answer for a truly future-proof program means everything I'm highlighting here I would not need to change if I start processing a new file type. We'll see how that can work, and indeed it will work, in our next video. I look forward to seeing you then. Thank you.